Hello class, today we're going to be doing lesson 12, which is titled Double Number Lines and Ratios. The question we seek to answer by the end of this lesson is, how can double number lines be used to display equivalent ratios? If you recall, we've been figuring out different models that we can use to display equivalent ratios. We started out with tape diagrams. We moved into ratio tables, and now we are looking at double number lines. Okay? In order to solve this or answer this question, we need to perform a task. And that task, when drawing a double number line, all we do is we draw two parallel number lines. Okay, here's line number 1 and line number 2. Line them up above each other. Then the top line is going to be used for our x value. So this red circled line is for the x value, and the bottom line is for the y value. So this blue circled line is for the y value. Then you just line up your points. I know that sounds a little bit confusing, but really it's essentially the same thing as a ratio table. Whereas in a ratio table, the first column is the x column, and the second column is the y column. You just turn it on its side, and it looks like a double number line. So, in order to practice this, we're going to use the example of 3 to 8. So we are going to draw a double number line and show ratios that are equivalent to 3 to 8. Since we're starting with 3 to 8, that has to be our first ratio on our number line. So everything starts with 0. Then our first mark along this x value line is going to start with 3. And we just draw a line down, connecting it to our y line. And we're going to mark that with an 8. And it's as simple as our ratio tables when you just skip count each new line by counting by whatever your first number is. So if our first value is 3, we count by 3. 3, 6, 9, 12, 15, 18, counting by 3 each time. Now down here, if we're starting with 8, we just skip count by 8. 8, 16, 24, 32, 40, 48, and so on and so on. And this could go on forever and ever on both sides, just like that. So we are going to try and use this double number line to answer this question. Use this number line to find the y value if the x value is 12. So we're going to come along our number line here on the x number line to try and find 12. Oh, there's 12. Alrighty, we've got 12. The corresponding y value to the x of 12 is 32. So our solution down here says if the x value is 12, right here, the y value is 32. We just drop it down. The key for these number lines is just learning how to draw them correctly. If you can draw them correctly, you can figure out all the different equivalent ratios that you're looking for. Now, it's really easy to find a y value when you're given an x value that's on the number line. Like, for instance, let's say I wanted to find the y value if my x value is 18. If my x value is 18, I just bring it straight down, and it's 48. You can do it the other way. What's your x value if the y value is 16? So if we know our y value is 16, just bring it up. Our x value is 6. It's that simple. Now down here, for our extension activity, it's going to be a little bit more challenging. Now the extension activity is something I'd like for you to do and follow along with me, but it doesn't have to be written in your notes. There doesn't have to be copied directly. If you'd like to do it with me on this notes sheet, you can do it down here in the bottom area, or if you have extra space on whatever page you're on, or if you want to use an extra sheet of paper, that's fine. But track with me here. I'm trying to figure out what, if my x value is 17, what is the y value? Now, if you look here, we don't have a 17. We go from 3 to 6 to 9 to 12 to 15, and then we go straight to 18. 17 is going to be somewhere here in between. Okay. Now there's two ways we can solve this problem. I'm going to show you the first way right now. Zoom out a little bit, give myself some room to work. Oops, I gotta get rid of this. Well, 17 here. So if you recall, whoa, that was an accident. Keep doing it. I guess I don't know what I'm doing. So either way, one way that we can figure out what our y value is if our x value is 17 is to figure out what the multiplicative constant is. And if you remember from yesterday's lesson, we said that in order to find the multiplicative constant, you must divide the y by the x. So divide the y by the x. Come over here, give ourselves a little bit of room to work with over here. Now, if we're dividing our y equals 8, and our x equals 3. And if we're dividing it, all we have to do really is put a little division bar in between. So our multiplicative constant is 8/3. So all we have to do, we take our 8/3 and we multiply it by any ratio, or sorry, any x value on this double number line. So let's take a look at, we'll just maybe take a look at 6 to 16. So all we need to do is multiply 6 by our constant of 8/3, and that should give us 16. Come back over here, give ourselves a little bit of room to work. Let's see if I can delete this thing. Okay. So if we are taking our ratio of 6 to 16, remember, multiply the x value by the multiplicative constant, which is 8/3. So let's take a look. 8/3, which we have here, multiplied by 6, which is our x value. Multiply straight across. 8 times 6 is 48. 3 times 1 is 3. Now we know this improper fraction can be simplified. We just divide the 3 into the 48. So we have 48 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtract 1, bring down our 8. 3 times 8, 18 divided by 3 is 6. And then our division problem is done. We're all good. And we see that our y value is 16. Does that match our ratio up here? If we multiply 6 by our constant of 8/3, we get 16. Looks good to me. So let's backtrack here. If our, let's see here, if we are trying to figure out the y value for an x value of 17, all we do is we take this 17, multiply it by our constant of 8/3, and see what we come up with. So, give ourselves some room over here. Let's do 8/3 times 17. Okay, 8 times 17, let's see that real quick. 17 times 8, we've got 8 times 7 equals 56, carry the 5, 8 times 1 is 8, plus 5 is 13. So we have 136 over 3 times 1 is 3. So we know that that's an improper fraction that we can simplify. Put the 136 inside the box, divide it by 3. 3 goes into 13 4 times. 4 times 3 is 12. Subtract, bring down our 6. 3 goes into 16 5 times. 5 times 3 is 15. That leaves us with the remainder of 1. So let's take that 1, make it our numerator. Our divisor out here becomes our denominator. So 45 and 1/3 is our y value, because our constant of 8/3 times our x value of 17 gives us our y value of 45 and 1/3. So let's come on back over here. And to answer this question, if the x value is 17, what is our y value? We know because we just solved it. It's going to be 45 and 1/3. Hope that helps. We can explore this more tomorrow. And we divide our y, which is 8, by our x, which is 3. That should give us our multiplicative constant. So we can look at it as 8 to 3. That's a division problem, but we'll get to that in just a second. Let's divide 3 into 8. 3 goes into 8 twice. 2 times 3 is 6, with the remainder of 2. So we have 2 and 2/3. Do we not? Looks good to me. 2 and 2/3 probably isn't going to work if we're trying to multiply, though. This is our multiplicative constant, but it's hard to multiply mixed numbers. So let's turn 2 and 2/3 into an improper fraction. If you recall, the way we do that is we multiply the denominator and the whole number. So 3 times 2 equals 6. And then we take that 6, and we add it to this 2 up here. 6 plus 2 is 8. So 6 plus 2 equals 8, and we keep our same denominator. So our multiplicative constant is 8/3, and 8/3 is the same thing as 2 and 2/3. So let's take our 8/3 and multiply it by our x.